Okay, so now we're going to move on to density. Density is an intensive physical property. It is defined as density is mass divided by volume. Okay, so what is an intensive property? An intensive physical property is one that is independent of the amount of substance that we have. So what that means is if you have 100 grams or 1,000,000 grams of gold, the density is going to be the same. All right, so we're going to look specifically at mass and volume when it comes to density. The density of a substance, everything has its own density. Density can be affected by temperature, if it's a liquid or a gas. But let's just right now focus on this equation in order to get the density of a substance. All right, so let's look at this problem. Mercury has a density of 13.6 grams per centimeter cubed. What is the mass in grams for 95 milliliters of mercury? Okay, so first I need to tell you, and this is something that you should write down for later, 1 milliliter is equal to 1 centimeter cubed. Density is, oh, that's a terrible D, but density is either going to be in the units of grams per milliliter or grams per centimeter cubed. They're interchangeable, so it doesn't really matter. All right, so let's look here. We know that density equals mass divided by volume. So we're given a density, 13.6 grams per centimeter cubed. And that's going to equal, I'm looking for my mass, so I'm going to leave that as M. And then it gives me 95 milliliters. Okay. I can just cancel this out to be milliliters. So I'm going to cross multiply. So the mass is going to equal 13.6 grams per milliliter times 95 milliliters. So the mass will equal 13.6 times 95 is 1,292 milliliters cancel, and I'm left with grams. Now, let's talk about significant figures. I am multiplying here. So I have 3 significant figures and 2. So this answer should have 2 in it. So I'm going to round that to 1,300. 1,300 grams. Sorry about that. 1,300. Rewrite that again. 1,300 grams. Okay. We can see that more detailed here. We can just plug it all in, just like we saw. Rearrange the density formula. So mass is equal to density times volume. Plug it all in, and get 1,300 grams. This is just another way of saying 1,300. All right, so now, actually, one thing to note about density is the only way for you to convert between a mass and a volume for a given substance. So you need to know the density to do it. I'm going to give you a very, very brief introduction to energy and the units associated with it. We're going to have a whole chapter on this, so we're not going to spend really any time at the moment on this. So we know that physical and chemical changes require energy. Now, that energy may be lost or it may be gained. But what is energy? Energy is the capacity to do work. And what is work? Work is the action of a force applied across the distance. So if you're pushing a heavy box, you're doing work. And the force is the weight of the box. So over a certain distance. Now, a couple things to know about energy, and again, we're going to spend an entire chapter on this, so this isn't something you truly need to know at the moment. But energy in the universe is conserved, and what that means is energy is neither created nor destroyed. It's always the same. It's just changing. It's just going from one place to another. That is our first law of thermodynamics. Everything possesses some sort of energy, whether it's kinetic or potential. Kinetic energy is the energy of motion, and potential energy is stored energy. Energy can always be converted from one form to another. Okay, so like I said, energy is neither created nor destroyed, so all the energy of the universe is conserved. Again, that's our first law of thermodynamics. When we get to this chapter, we're going to look at energy exchange between what we call a system and a surroundings. Our system, for the most part, is generally going to be a chemical reaction, and the surroundings is going to be everything around it. But you add those two together, and it will give you the energy of the universe. When we're measuring energy, one way we measure it is we measure it in what we call heat flow. Heat is a form of energy, obviously, and when we measure it in terms of heat flow, we look at what we call an endothermic reaction or an exothermic reaction. An endothermic reaction is when heat transfers from the surroundings to the system. So what that means is that the system, let's say your chemical reaction, is going to take in energy, and it needs to take it in for that reaction to happen. When that happens, the temperature of your surroundings will go down. An exothermic reaction is when heat is transferred from the system to the surroundings. This is when heat is released. So endothermic heat is absorbed, exothermic heat is released. And when we're talking about the surroundings in an exothermic reaction, the temperature will go up. There's lots of energy units, and here are some of them. We have a calorie, which you guys know. This does deal with heat calories or nutritional calories. And we'll go over these in much more detail later on. For now, it's just something, a word for you to understand. So we have calorie, kilocalorie, which is just, there's 1,000 calories in a kilocalorie, joules, and we'll just leave that there.